Shafiq Umar Azhar. My metric number is 8812300, and I will be talking about system 1. For objective 1, GS is 1 per S times 2. HS is 1 because it's unity feedback. So for MS, G, or using formula G over 1 plus GH, the answer will be 1 over S equals to 2 plus 1, and this is the zeros and poles. This equation will have no zeros, and the poles will be 1 and negative 1 at imaginary. Objective 2, from the simulation, I am able to obtain the graph, and the result is the graph is marginally stable. There is unknown overshoot, unknown rise time, unknown settling time, and infinity steady state error. For objective 3, I choose PD controller to meet control system design requirement. For my KP value is 5, KI value is 0, and KD value is 100. My controller is stable because it has 0 overshoot, 0.0219 rise time, 0.0389 settling time, and 0 steady state error. This is the graph that I obtained from the controller. For my next, for my second most accurate controller is PID controller. KP value is 5, KI value is 5, and KD value is 100. This PID controller is stable because it has 0 overshoot, 0.0219 rise time, 0.0389 settling time, and 0 steady state error. It is similar to PD controller graph, but the difference is at the graph. As you can see from the PD controller, it doesn't oscillate just like a PID controller. This graph PID controller, it still oscillate between 1 and 0.999. So I choose PD controller to be my controller. Okay, my third controller is P controller. The KP value is 5, while KI and KD value is 0. This system is marginally stable because it doesn't have overshoot, none overshoot, none rise time, none settling time, and infinity steady state error. And this is the graph that I have received from the system. And lastly, PI controller. KP and KI value is 5, and meanwhile KD value is 0. It is unstable because, as you see from the graph, from stable it went unstable. Overshoot none, rise time none, settling time none, and steady state error is infinity for this system. Thank you. That's all from me. Thank you.
Hello, my name is Muhammad Fikri Akmal bin Abdul Razak. My number metric is 212158. Now, I will present about my part in this project. My part in this project is question number 2. Okay, for the objective 1, determine stability of a closed loop control system using pole zero plot. Okay, for objective 1, from the conclusion, I get this as an answer. Okay, then the pole is at the negative part, so it is stable. Next, for the objective 2, stimulate the closed loop system to obtain the step response. First, develop the closed loop system shown in table 1 using MATLAB simulation. Then, set the step input as per the following, and the third instruction is run this simulation, and the fourth instruction is observe and record the step response for each closed loop system. And the 5, for the stable closed loop system, determine whether it's underdamped or overdamped or critical damp. And number 6 is determine the tabulate the overshoot, setting time, rise time, and steady state error. And the 7, discuss your result. From my result, I can get it is this. It is my Simulink. I put this and I get this graph. So from this graph, we know it is stable. Okay. See, the it is stable and its overshoot is 55.2080, and rise time is 0.224, and setting time is 3.7156, and steady state error is 0.31. Okay, next we will talk about the next objective. For the next objective, we must implement P or PD or PI or PID controller to meet control system design requirement. So from the question, you can know that we must get a stable graph using a P or PD, PI or PID controller. From this objective, I can show 5 examples from what I can get. For the first PID value that I use KP is 5, KI is 5, and KID is 5. And it shows it is stable, and overshoot is 0, and rise time is 0.227, and the setting time is NAN, and the state error is 0. This is my Simulink programming, and this is my graph. Next, the second example that I use is only I and D. The KI I put 10 and KD I put 11. It is marginally stable, and the overshoot is 0, and rise time is 0.0103, and setting time is 0.205, and steady state error is 0.11. This is my programming, and this is my graph. The next one is I just use I controller only, and I put 10. It is unstable, and I got overshoot is none. Rise time is none, settle time is none, and steady state error is infinite. See the programming, and from the graph you can see it go straight and then bounce. Okay, next example is I only use D controller only. It is unstable, and overshoot is infinite, and rise time is 0, and settle time is none. The steady state error is also none. This is my programming, and this is my graph. And the last one I can get is stable also, like the first example, but I use the PID value is KP is 150, KI is 150, and KD is 10. It is stable, overshoot is 4.0620, and rise time is 0.094, and setting time is 0.0476, and the steady state error is 0. So we know the graph is stable. This is my programming. You can see, this is my graph, and you can see the amplitude is 1, so the steady state error is 0. That all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Furqan bin Fin dan nombor matrik saya A212279. Okay, hari ini saya akan membentangkan tentang projek control system bagi sistem nombor 3. Okay, objektif yang pertama, sebelum kita start pada objektif utama, inilah sistem nombor 3. Dan objektif kita beralih kepada objektif utama. Determine stability of closed loop control system using pole zero plot. Okay, first kali dia minta kita buat pengiraan. Selepas itu dia meminta kita untuk menggunakan MATLAB untuk tunjuk result yang bagi pengiraan kita sama ke tidak. Okay, first pengiraan kita keluarkan kita punya equation daripada sini, transfer FCN. So G kita sama dengan 250 over S squared tambah F4S tambah 50. Dan kita punya sini ada feedback. Feedback kita ni ialah 1, iaitu unity feedback. Okay, F kita sama 1. Dan kemudian kita combinekan G dengan F ni. Okay, kita boleh tengok ini yang formula dia. G over 1 plus GF. Then, okay, kita masukkan nilai. Okay, selepas masuk nilai, seperti ini, 250 over ini. Dan, bila kita kembang-kembangkan, ada tolak tambah. Dan kemudian kita akan dapat nilai macam ni. Bila kita dapat nilai ni, yang atas ini kita untuk mencari zeros. Untuk nilai bawah ni, kita untuk cari poles. So, untuk zeros, kita tak ada nilai sebab dia tak ada S kat situ. Kalau untuk poles, kita guna just tekan calculator sahaja kita akan dapatkan nilai poles. Iaitu kita akan dapat poles pertama pada paksi X negatif 2 dan pada imaginary positif 17.2. Dan bagi poles kedua, negatif 2 bagi paksi X dan imaginary negatif 17.2. Okay. Selepas apabila kita dah settle ni semua, kita tengok pada kita run pada MATLAB. Okay, kita boleh tekan macam ni dan kita gunakan PZMap T untuk keluarkan graf. Okay, seperti yang kita boleh tengok, sini ada poles dekat sini pada garisan berhampiran dengan 17.5 dan di sini pun sama negatif 17.5. So kalau kita tengok pada paksi X di sini bawah ni, negatif 2. So kita punya result sama dengan pengiraan dengan pada MATLAB sama. Okay, so the system is stable system because of it have closed loop transfer function with 2 poles in the left half plane. So kedua-dua poles kita sebelah kiri, plane belah kiri. So itu menunjukkan kita punya sistem stable. Okay, objektif kedua dia minta kita simulate the closed loop system to obtain the step response. Okay, seperti biasa kita gunakan MATLAB untuk tengok sistem ni macam mana untuk dapatkan step response. So kita gunakan clock equation macam ni, G equal to TF dengan ni belah atas numerator dan ni denominator kalau tak silap saya. Then lepas tu kita keluarkan T sebagai kita punya feedback untuk G equation tadi dengan feedback kita F kita adalah 1. So kita akan dan kemudian apabila dapat kita tekan step info T dan ini kita akan dapat rise time 0.0659 transition time. Okay, dan kemudian step T untuk keluarkan graph. Okay, ini graph untuk the whole system untuk sistem 3 without a controller. So graph ni dinamakan sebagai underdamp dan underdamp ni ada kategori dia boleh dikatakan stable graph and stable system. Okay, so kalau kita lihat closed loop system nombor 3 ni stable and overshoot dia 69.3900% and rise time dia 0.0959 dan settling time dia 1.8667 and steady state error dia daripada nilai kita ambil satu ni dengan steady state value 0.168 hasilnya. Okay. Kemudian selepas tu ini untuk tanpa PID dan objektif ketiga kita dia minta tambahkan controller P, PD, PI dan PID untuk lengkapkan untuk design requirement untuk lepas tu seperti kalau dalam implement ni saya telah menggunakan PD dan PID kerana kegunaan P ni adalah untuk reduce steady state error dan I eliminate steady state error dan D dia reduce semua kecuali dia reduce overshoot, rise time, settling time, kecuali steady state error dia tak reduce ataupun limit data. So sebab tu saya gunakan PD dan PID, sebab kalau kita gunakan P sahaja tidak mencukupi dan PI pun tidak mencukupi. So di sini kita ada PD dan kita ada PID yang boleh dikatakan memenuhi syarat-syarat yang diperlukan lah untuk soalan kali ini. So untuk controller pertama saya gunakan PD dengan nilai 32 untuk KP dan D ialah 7. Okay, stable tu stable, tapi overshoot dia 0.5441 agak tinggi juga. Dan rise time dia 0.012 boleh tahan, dan settling time 0.021 dan steady state error dia sangat rendah 0.001. Okay, untuk kita gunakan dekat MATLAB macam biasa kita keluarkan macam biasa macam first tadi, cuma kita tambah lagi untuk sebagai kita pemula buah kedua G2 equal to PID. Kita letak kita punya controller, kita letak kita nak guna P nilai berapa and D berapa. Kalau I kita guna, so kita letak I tu sebagai kosong. So kat sini kita boleh nampak kita gunakan KP dan KD sahaja. Dan kemudian untuk G3 kita gabungkan nilai G2 yang pun boleh untuk PID tadi dengan kita punya equation pada awalnya iaitu G equal to TF. So nanti kita akan dapat equation seperti ini, dan biasa kita keluarkan T sebagai feedback kita untuk yang G3 ni, dan akan dapat kita punya nilai equation, dan kita tekan state info untuk dapatkan nilai rise time, transition time semua, dan step T untuk dapatkan hasil graf. Okey, ni hasil graf dia. Ni dikategorikan stable graph. Okey, cuma kalau kita nak bandingkan graf ni dengan yang graf bawah ni pun sama je, cuma kalau kita lihat daripada segi nilai. Okey, ni saya untuk yang kedua ni saya gunakan PD juga, cuma dia punya KP agak tinggi 65 dan KD dah 7. Dan kita boleh lihat overshoot dia kat sini kurang dekat 0.6 jugalah perbezaan dia, 0.006. So dia turun banyak juga di situ, tapi still macam tak memuaskan walaupun steady state error dia telah mencapai 0. So tapi apabila kita letak KP dia terlalu tinggi, KP ni dia increase overshoot, dia increase rise time, settling time, tapi dia cuma reduce steady state error. So sebenarnya nanti dia akan banyak dia banyak oscillate tu. Okay. Lepas tu kita buat benda sama, just kita ubah nilai saja. Alright. Dan untuk yang kali kedua, untuk yang kali ketiga punya, saya gunakan controller PID. Okay, sebagai permulaan saya gunakan KP kita sebagai 111. Okay, seperti yang boleh lihat, kita punya overshoot terlalu tinggi, and rise time kita pun boleh tahan, settling time pun terlalu tinggi, dan steady state kita dapat negatif 0.01. Dia terlebih sedikit kalau tengok pada graf. Graf dia pun agak pelik. So okay, benda sama kalau kita guna kat MATLAB, cuma kita ubahkan PID ni, kita letak nilai I sahaja dan tambahkan nilai I sahaja. Alright, then last kali saya gunakan PID dengan nilai 127. Seperti yang kita boleh lihat, overshoot kita dapat 0, rise time kita kurang, settling time dan steady state error kita pun 0. So ini dikatakan tepatlah dengan kita punya ciri-ciri yang mahu untuk soalan ni, untuk objektif 3. Dan graf dia ni pun sangatlah smooth dan kemas. Kalau katakan kesemua graf ni adalah sama kecuali graf yang ini sahaja yang berbeza. Walaupun graf ni dikategorikan stable, tapi tak ditepati dengan ciri-ciri kehendak soalan. So ini sahaja yang betul-betul tepat pada ciri-ciri soalan minta. So inilah jawapan yang betul-betul yang kita mahukan. So kita gunakan controller PID yang nilai 127 dan stable sistem kita akan dapat overshoot kosong, steady state error kita kosong, shifting time kita rendah 0023 dan runtime kita pun rendah 0013. Okey, sekian itu saja daripada saya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abu Sufian Azmi, and I will present to you about our group project, where our project is to make a stability analysis and using a PID controller. So we were given 4 different closed loop system where we need to simulate and to find either the system is stable or not. So I was doing the fourth one. This was the closed loop system. Before we doing the stability, we need to know either the system is stable or not. So we using two method. First is finding the pole zero plot. So we need to calculate and to find the pole zero plot either the system is stable or not. And secondly, we will simulate the system to obtain the step response. And lastly, the last objective for our project is to using a PID controller to make the system stable. So we need to achieve the requirement is we need to make sure the overshoot for the system is less than 10%, the settling time is less than 5 seconds, and also we need to make the system steady state error is less than 2%. So we go into our system, where we need to find either the system is stable or not. So by using the pole zero plot, so and the calculation. So where we using is we need using a formula where TS equals to G over 1 GF, where the G is this one, the transformation number 1 is a G, and the transformation number 2 is the feedback. So we calculate and we gathered we have 3 poles and 1 0, where by using Simulink we got to know that the system is not stable because the zero plot was on the right side, not on the left side. So they have 3 zeros, and also it showed that the system is not stable. So we simulate to confirmize the system is not stable. So we simulate the system, the closed loop system, to obtain the state response. So it showed that the state info also show that the rise time and also overshoot is non-value because the system is not stable. Based on the graph, we can see that the oscillation of the system is not stable. Then all the value we cannot obtain because the system is not stable. So we need to use a PID controller to stabilize the system. So first we're using a KP controller where the value is smaller. That's when we using a 10 for KP controller. So when we use a value of 10, KP is equal to 10. So we know that the system is stable. It's still stable, but the oscillation of the system is too high and overshoot is too high. It's not under our requirement where we need to know the overshoot is less than 10%, but the system is also stable because the requirement for this project is not achievable because overshoot for the system is more than 10%. So what if we increase the KP controller? We're using 100 and 1000. Because of this, the oscillation of the system become bigger because KP controller when we increase the value, the oscillation of the system become larger. So the overshoot is more than 10%, but the system is stable, but the requirement is not achievement. So we need to use not just KP controller, we need to use KI controller. So we're using both controller KP and KI, where the value is same, 10 and 10. From this value we got is still stable, but the overshoot is too high. So we need to make sure that our system is under our requirement. Although the system is stable by using a KP and KI controller, but the system still not under our requirement, where we need to do the overshoot is below than 10%. So, but from our experimental, what if we increase the KP controller and still it become unstable? Because when we increase the KP controller to the 100 and KI to the 10 values, the system become unstable because of the KI controller is for to minimize or reduce the steady state error. But when we increase the KP controller, the oscillation become high, but it's not in the middle but in the end of the control. That's why the oscillation we see here is not stabilized. So the system becomes unstable if using a larger value of KP controller. So we need to use, to reduce the oscillation and overshoot, we need to use KD controller, where I was using KP controller value is 30, KI is 10, and also KD is 10. So when using this three value and introduce a KD controller, the system become stable and all the requirement that are achieved. So overshoot is become 0%. The resistance time is below than 2 seconds, where is equals to 8.797 exponent negative 4, and the settling time is lower than 5%, so 5 seconds if I'm not mistaken. I think the settling time is for our project is sorry about that. Is we need to make sure the settling time is below than 2%, 5 seconds. So the steady state error, when we introduce the KD controller, if the steady state error become 0, almost to 0, it becomes 0. It's not almost, it becomes 0. So settling time is less than 2%, 2 seconds, and the settling time is less than 5 seconds, and overshoot is 0. So and when we see on the graph, it becomes stable. It's no oscillation. Just we got undamped graph, where we get the underdamped graph. So the system becomes stable, and that's why we need to use all the PID controller to make sure the system is stable. So that's all for me. Thank you.